Hello, my name is Richard, and I'm here to talk about my summer research project, and it was directed by Dr. Hurtado-Lange, and the topic is data processing for hospital arrival rate. The purpose of this research is to compute a method to predict the arrival rate in hospital. Ideally, we would want to compute queuing performance measures since we want to know at a specific time t how many people are waiting or like what is the estimated waiting time. In order to do that, we would need to look into the arrival rate data. And the main tasks are two. One of them is to reduce noise in the data set, and another of them is to generate a piecewise function, also known as a step function. The reason why we want to generate a piecewise function is that computing the queuing performance measure, as we said, it is generally an intractable problem, meaning that it is pretty hard to solve in mathematics. So the best we could do is to use past information we obtained to make an accurate prediction of the next period of time. The first approach we took was moving average. A traditional moving average would be taking a look at all the data points in the past and just take a plain average of them to predict the data points for tomorrow. However, that is not very effective because if there's a data point that's like way back in the past, we wouldn't really want to consider that. So our modified moving average is that we define an interval TA, and then this see if this A is 10, and then we would be looking at 10 data points in the past. And we just look at 10 data points in the past, and then we take the average of these 10 data points, and which is stated here. With the moving average algorithm, we use Python code to generate the step functions. Stationary data is on the left and transient data is on the right. We both wish to analyze them. We define, since we're asking for step function, we define n k as the number of intervals we want in the plot. For example, you see k equals to 10 here, and there would be 10 intervals in the step functions. We figured that k equals to 10 is a balanced way to go. It's not so populated while it would captures the trend of the data. And we also developed an efficient way to apply the moving average filter while generating a step function. So in this new algorithm, even we are working with a much larger data frame, the plot or say the sorting will still be very efficient. The major problem with moving average is that it gives all the same weight to the past data. We can technically reduce the window size in moving average, but we do need sufficient amount of data to make an accurate predictions. So this led us to think about exponential smoothing. Exponential smoothing is like a moving average with weight we can give to the data. We define a weight alpha, that prediction for the day t will be alpha times the data we collected at day t minus 1, and y minus alpha times the prediction we made for t minus 1 at t minus 2. So shown here is our definition. We can see that it makes sense because we are giving the most recent data the highest weight, and think about how we generated st minus 1, so which is like the prediction we made. We made this prediction by a recursing progress, and in this recursing progress, we're just giving a smaller and smaller weight to the past data. We also want to do exponential smoothing as how we did moving average. So we did some mathematical calculations, and this is also a major progress in our research here. We figured out how to do exponential smoothing with given weight alpha and a given interval a that we are looking back at, and this is the result we got here. In order to see the advantages of exponential smoothing, I plotted out two graphs here. The exponential smoothing on the right is rather a traditional one. It's not looking at an interval. It's looking at all the data in the past. I feel like this is more it captures like what naturally is the exponential smoothing is. If we use a modified exponential smoothing, I believe the R square value will be slightly higher. But we could see this difference here already. Like the R square value is higher and there is less lag in the data. It is a little bit noisy, but when we convert it into a step function, it will not be a problem. After obtaining the data sets, after obtaining the step functions, we have the ability to fit it into time series models. The intention is to try and use a Riemann model to feed our data sets here. This will give us a chance to do simulations and to prove some theoretical contents. My major job during the summer is to process the data and to prepare it for the time series analysis.